Hello everyone, we had 3 consecutive lectures on reviewing the theory, and this lecture will go directly to the field and will roam around Ghatshila, particularly in Harindungri and some other places, also in Ferighat, to understand and see different kinds of superposition of folds. In this lecture, we will particularly focus on the form surface, and these form surfaces could be S0, S1 or S2. At the same time, we will also see, because of the folding of these form surfaces, we will generate multiple sets of foliations, or in other words axial planar cleavages. We will try to interpret their mutual relationships. We will measure, we will show them how they are disposed in the stereo nets and so on. Let us get started. So, now we will focus on the folding that has happened in this exposure, and the folds are, as you can see in this area, is expressed by a lot of asymmetric folds. So, again these are the traces of S0 on this surface. So, we are looking at a vertical surface, and you can see that if I mark this one, focus on this one, you see beautiful asymmetric folds. Going on like that. You can see asymmetric folds also here in this layer, like this. And if you look carefully, the fold axis of this goes in this way, okay, here, for example here. So, if you have a fold, asymmetric fold, which in this case is somehow like that, like this, and this is your fold axis, then axial planar cleavage of this particular fold should be like this. So, again let us repeat our nomenclatures. These are the traces of the S0, that means the primary bedding surface, and if this S0 gets folded, then that fold is F1. So, we are looking at F1 folds in this form, here and here. The fold axis of F1 is like that, here, here and here in this form. So, therefore, S1 should form in this way, and if we come here in this surface, we actually can see the exposed S1, and interestingly both S0 and S1, they are almost parallel or subparallel or at a very low angle to each other, and that tells us, first interpretation from this is that we are at the limb of a major fold, and all these asymmetric folds also support this interpretation. Now, if we closely look on the S1 surfaces, which are these surfaces, we see that S1 surfaces are also crenulated, and these are the crenulations you can see here. So, if S1 surface is crenulated, that means we are developing F2 over S1. So, S1 is a continuous foliation or continuous cleavage here, and F2 is developing over S1 or has developed over S1, as you can see in all places, here, here and here, they are going like that. So, they have to be spaced because these are crenulated. So, S2 then falls in a very similar fashion. So, in this surface we cannot see S2, which should develop because of F2. We will see on a horizontal section S2 and identify whether the S2 is parallel or perpendicular to F1, but meanwhile you can think that what it should be. What we further see here, that we have identified F1 is this way, this is the F1 fold axis, and crenulations are also in this manner, and therefore we can conclude that this one was our F1 and this one is F2, and we clearly see that they are parallel to each other. So, we again conclude from this exposure that F1 and F2 are coaxial. To prove it further, we have measured the data from all these places, and we also got some direct fold axis measurement of F1, and we plotted them on the stereo net, and then we will see that how we can actually tell what is the deformation features or related geometries in this area. What we are seeing in this exposure is between the first quartzite band, the thickest quartzite band, and the next one, the medium thick quartzite band. We are on this alternate quartz and mica schist layers. And what we have just seen in this exposure, that here F1 and F2 are coaxial. We have seen in this place that F1 folds are essentially asymmetric. So, if we see them, they are going like that, and if they are not, so I am trying to make them fold axis vertical, they are like this. So, these are the F1 folds. And so on. Now, if F2, as we have seen, because of this we are forming the axial planar cleavage of the F1 fold almost subparallel to S0, which is this one, and then S1 is coming like that. Now, if S1, we have seen that S1 showed some crenulations, in the second stage of deformation, and therefore, this fold of S2 giving rise what is called F2, and F1 and F2, as you can see, they are parallel to each other and therefore coaxial. Now, what is happening with the S0 as a result of F2? So, essentially S0 is also getting folded. So, you can think of that if S0 is getting folded further by F2, which has already been folded by F1, then the hinge sections particularly will get modified, and they probably will take a shape like that. You may also expect some minor folds here, or you may not, but the hinge sections would be greatly modified. And if we now try to see this in third dimension, we can figure out that these things were F1 and we have generated one more curvature here, this one. These are giving rise F2. So, therefore, this is a fold superposition of type 3. This we know from our theory lecture. I mean type 3 as classified by Professor Ramsey. And the typical outcrop pattern of type 3 is hook. Now, in this area what we are seeing, the fold axis we have just seen and measured, they are not vertical, they are at an angle, and therefore, the appearance of hook pattern is little apparent, and you may have to stretch your imagination to understand that, because we do not have a proper section to see this. So, what you just see this image, remember this image, particularly say for example this section, and try to stretch your imagination to fit this part that we are looking at. So, this is S0, and here you can see that this is folded, giving rise fold axis F1, which is going in this direction, and F1 has formed, which is at very low angle. So, you can see the traces of F1 S1 are going like this, and S2 F2 is here, you can see the crenulation of S1 falling like this. So, therefore, F1 and F2, so this was F1 and this is F2, they are parallel to each other and coaxial, and this we have already demonstrated and understood. But as a result, we can see because of F1 and F2, S0 is giving like a hook shape, and because F1 here is not perpendicular, so we can actually visualize the fold in this manner. So, it was like this, and you can see if you just stretch it in this form, it appears this way. So, it is coming and then getting around and then coming back. This one and this one and this one, this and this are F1 and this one is F2. I repeat, this is not a very ideal section to look at the superposition outcrop. For example, in this case we expect hook, but this is the closest I can demonstrate you from this exposure. We hope to see some more features and show you later. So, we are also in a very little exposure here, and we will examine the overprinting relationships, as this particular exposure displays a number of features. I hope your eyes are more or less set right now to understand, at least through the visual ways. We see the trends of S0. I am marking this particular place here. You can also check it here. So, S0, as you can see here, it is folded, and this I am marking it here is defining the F1. S0 got folded, defining the F1, and all these surfaces that you see, these traces you see and these surfaces here, these are produced because of F1, and therefore, all these are S1 surfaces. On this S1 surface, we see one set of crenulation this way, you can see that, this way, and another set of crenulation, it is prominently developed here this way, you can see this. So, this particular surface S1 has two sets of folds, one this one and another this one. Both are given by crenulations, and therefore, formation of S2 and S3 because of this fold and this fold should be spaced, whereas S1 is continuous. Now, you see we have identified that F1 and this particular fold are of same orientation and they are coaxial. So, this is F2, and regionally we will see when we will do the map that this orientation has changed at some places, but this orientation remained constant. So, which one is first, this one or that one? To understand that, we have mapped the entire region and found that both this orientation and its axial planar cleavage S2, that is this orientation, have changed significantly in this region. But this one, fold axis and its axial planar cleavage S3, they remained constant throughout this region. So, that helped us to conclude, and we have already said it when we saw only these two, that F1 and F2, therefore, I define this as F2, they are coaxial, and then F3, which remain constant throughout the area, is the third fold, and therefore, I call it F3. So, in this small region, you see we see S0, which is folded. Folding of S0 gave you S1, which is this surface or this surface. This S1 surface got folded twice, first in this manner by a crenulation, giving rise S2 spaced foliation, and then the entire packet got further folded in a crossed manner, giving rise F3 in this direction, again manifested by crenulation, and therefore, S3 is also spaced here. So, we are reiterating the same statement that if you form folding on S0, the foliation should be continuous foliation, and all successive generations, at least in low grade metamorphic rocks, should always be spaced foliation. And in this region particularly, we have measured all these orientations, the general trend of S0 wherever we found dip and strike, S1 we measured dip and strike, S2 wherever we found we measured dip and strike, S3 wherever we saw we measured dip and strike, and at the same time we also measured the fold axis of F1, F2 and F3, and we plotted them regionally, and we will show you later that how they are related in this entire region, not only in Harindunguri village, but also in the entire Ghatshila region. Particularly, we will compare the Ferry Ghat and what we see here in the Harindunguri village. So, here we are also in a very interesting exposure. We have seen in this exposure that all other features that we just have seen in another exposure exactly on the eastern side of the youngest and thickest quartzite band in this Harindunguri region. There we have established the relationship between S0, S1 and S2, and here we also see the traces of the bedding planes. So, these are S0. This particular surface that we are looking at is actually S1 surface, as you can see here as well. S1 surface is a little curved because of the cleavage diffraction, but that gave us an opportunity to look at several other features. So, if this is S1 surface and these are the traces of S0 falling on the S1 surface, this, if you measure the trend and plunge of this lineation on this surface, that gives you F1. Now, you also see this surface, and this surface is crenulated, and as we have identified this crenulation axis as the axis of F2. Now, this F2, traces of F2 are also on S1. So, S2 here is also going like that, as we have seen on this exposure. So, therefore, the traces of S2 on S1 is also like this. We have seen F1 is like that, and we are seeing that traces of S2 on S1 are also like this. So, it clearly tells us that here F1 and F2 are parallel to each other, and therefore, we can conclude that in this area F1 and F2 are coaxial. And this we have established from our data and other things, even we have seen this in Ferrighat. Another most important feature in this surface is, other than the traces of S0 and F2 on this S1 surface, we see another interesting crenulation which have developed on this surface, and you can see they are going like that in the curved surface, and their general orientation here, axis orientation, is like that. So, what we see here, these are probably defining another fold, and you are right if you guessed so. These are the third generation of fold that have developed in this area, and these are the traces of the fold axis of the third generation of fold, or F3, and which is here, at least in this case, the cross fold. So, if I try to summarize here what we have observed, this is S1 surface. On this S1 surface, we see the traces of S0 and S2 defining the F1 and F2 fold axis, and we have taken their measurement and we have understood that they are coaxial. S3 is falling like that, and they are appearing as crenulations on this surface, and therefore, if we take this measurement, that will give you the orientation of F3. So, in this very small exposure, we have identified a number of features. In addition to all these, we also understood a very important mechanism, that S1, which is the first foliation that is axial planar cleavage of the major fold here, is a continuous one. All other two foliations, S2 and S3, both of them are spaced cleavage, and this is how it has to be. So, if you see a continuous foliation in the field, 99.9% cases, these foliations, continuous foliations, are generally S1, and if S1 further deforms and produces later generation of folds, the foliations due to these later generation of folds are essentially spaced foliation. So, here we arrive at the hinge zone of this third quartzite band that I was talking about in the previous section. What we see here, you can follow, these are the traces of the bedding planes, and then it turns here and then it goes here, it takes a further turn and goes in this direction. So, eventually it generates a fold here, and if I look from this side, you see this is the fold you are looking at, this is the fold axis, and when it turns back in this side you get another fold, and this is the fold axis. So, again if I look from this side, you see this is the antiform, and in the same train of the fold you see this is the synform, and this has happened here, and this is almost a tight fold. As you can see, we will measure this angle and show it to you. What is most important if we consider it and compare it with respect to Ferrighat is the fold axis. You see, the fold axis is almost vertical. The plunge of the fold axis here we have measured, it is close to 75 degrees, and this tight fold here makes the regional S1. You see the traces of the S1 here like that. Because this synform, this antiform and this synform is almost symmetrical here, the fold axis is going like this, and these are the traces of S1 on this surface and making the fold very much symmetric. In Ferrighat, we found the fold axis was plunging around 15 degrees. With the same S0 here, we find the fold axis is plunging extremely at high angle. It basically is making a reclined fold. So, that gives us a clear idea, the fact that here in this location we see the fold axis is almost vertical or is giving kind of a reclined fold, and in Ferrighat we saw that the fold axis were pretty gentle, close to 12 to 15 degrees, tells us that or helps us in concluding the fact that regionally the fold is not cylindrical, because the plunge of the fold axis is varying regionally. And if the fold is not cylindrical, that means the fold is non-cylindrical, there must be superposed deformation or superposition of folding. And this we have seen in many other places where we were looking at different fold superpositions in small scale. We have seen crenulation cleavages, we have seen crenulations forming F2, F3 and so on. The third quartzite band from this place also drifted or shifted because of this folding from its original trend, and then it follows actually the Lokchoria Nala, which is also following the trend of this quartzite band and flowing along its boundary. So, it is coming from my back and then going this way, taking a strong turn and now going towards north side. Axial planar cleavage and S0, that means bedding plane. So, S1 and S0, they interact in many different ways when they appear before us. For example, what we see here, we see the traces of the bedding planes going like this, and you can figure out that it is giving a very gentle open fold, and from your side of view it gives and antiform. Now, you see the axial planar cleavage, the traces of axial planar cleavage perfectly making it a symmetric fold. What is important to note here, this is a quartz rich layer, therefore stiffer. This has more mica, therefore less stiffer or softer. And because it has more mica, the concentration of axial planar cleavages here you see are more, and here you hardly see axial planar cleavages, or even if you see, they are not as concentrated as here. So, can you say that these are spaced cleavage here and continuous cleavage here? The answer is no. Because they are not here, that does not mean that they are not present, because we cannot see here does not mean that they are not present. Here they are strongly developed, but here not. But if you make a thin section and try to figure out the orientation of the quartz grains, you will figure out the presence of axial planar cleavage in the thin section. So, this is a beautiful place where we see that axial planar cleavages are perfectly developed as we see in textbook images. So, here we are looking at a small fold. As you can see, the fold is going like this and this way. So, because of this fold, the rock here, this rock is particularly a quartzite. So, it is a quartzite rock, and what you see outside this rock is mica-schist, and you can clearly see the traces of the axial planar foliation of this particular fold. So, this is S0 that is folded, and then because of that you have axial planar foliation going like that as your S1. What is interesting to see here, if you follow this foliation from here, then you see a part of it, this is the hinge and that is the hinge point, which are coming from this side is taking a curve, turning and running this way, and which are coming from this side taking a curve and running it this way, giving kind of a flower like structure. So, in this particular scene form that you are looking at, they are diverging away towards the hinge. So, this is an example of cleavage fanning. Thank you for your attention. With this, we finish the lecture number 13. In the next lecture, we will take you to a beautiful place called Tetuldanga, where we will see superposed folding in a single outcrop. Stay tuned. I will see you in the next lecture. Thank you.